Okay, it looks like we're on here. This is a something that just came to me in during this past week, and it's a step towards merging the JP-3 drill pipe to incorporating the GEE technology of Paul Pantine's. Actually merging the two technologies to where you would get your third model would be a hybrid of both, and it would actually do quite a bit more actually. And what you see here is your JP-3 SL. SL stands for steam. This is your steam insert. I've removed the soapstone slider in there, and I put in a machined piece of steel, stainless, and so this is going to get hot just by being in there, and the heat from the pipe, when you inject water spray into here, it's going to convert instantly into steam, and so that's the purpose of that. So this little steamer will not only just make your steam, but it'll also tune the pipe, so it'll be like an adjustment at the same time. And to get that to work, there's a little bit of modification on the JP-3. You still have your air and your fuel mix coming in on your second air gap, going around, so that hasn't changed. The only thing is, on your first air gap on the JP-3, that's no longer in service. That's been blocked off, and so the holes here can be just plugged off, and the air in the fuel mix is allowed to bypass the inside air gap and come right into the drill pipe itself. And this here is a liner. This pipe here is added. It's not part of the JP-3, and that might be something that you would make out of stainless steel, where you would machine the metal to rough it up and bathe it in ceramics, so you would have a very heavy duty stainless steel heat tube, just for the higher temperatures, right? And my friend down in Stateside, he's a machinist, and he said, well, stainless is better to use if you are going to use seawater as a fuel, where stainless is not affected as it affects other metals. Okay, so you basically have your JP-3, and you have this steam and this liner put in. That's the reason for the SL series. And so you have your vapor coming through and coming back and being injected inside the pipe, inside the drill pipe itself. And you may have to maybe put some washers around here, or just maybe float a washer on both sides so that the fuel actually goes right in. It may not be necessary, and that might be a possibility. That wouldn't be no problem anyway, because you could get it close, and you can be generating a little bit of pressure there too, so the air fuel is going to find its way. And you still have your positive feedback there. You won't actually need it, and but since this whole thing is going to be like a thermal insert or a core, it would complete the integrity of the drill pipe assembly. And so you're using the positive feedback on the exhaust. You could use that to feed that directly into a Stirling engine or whatever to generate or convert your heat into mechanical energy. And it's also going to help to preheat your fuel. So you can just have like a partial feedback coming, and the rest can go out there. And so the purpose for this is if you want to upgrade to using steam on the inside. Right now, the pipes are probably running about 1800. The core of the flame is always hotter than the outside. You see the outside of the flame, outside of the pipe getting hot, that's actually the outside of the flame. And the flame is a vortex, and so the eye of the vortex is much hotter than the outside of the vortex, right? And but generally speaking, you're pushing around about 1800 degrees, and if you were to shoot a little bit of water into here, it would instantly convert into steam, and you might be able to pulse this in, right? And so you could actually have a pulse system, which would allow the pipe to not get overly hot. But you're probably going to boot it up from 1800 to 2100 degrees, maybe over the 2500 mark. I'm not sure. It's just gonna be hot, and but to give you that extra boost in case that you ever need it. And if you don't want to use the liner, you can design this system so the steamer part can still remain, and you'd have be back to your conventional JP-3 assembly without the liner. So there is a little bit of room for play here, and but basically this is kind of leading toward the gate, and so the next escalation on this would be to remove this and put in the gate reactor, and I'll draw this in a bit. And the gate reactor might end up being a separate system to be hooked into a dual Joe pipe assembly. And so see, if this was the gate was in there replacing the tube assembly, your exhaust is going this way, and your reactor flow would be going this way. So this end would actually be producing your gate gas, and it might be you might be able to feed it back in, so you have a closed-in loop. That's possible, and you could also have this as a downscaled system to where you could plug another JP-3 going this way, like a larger version. So this whole thing would be maybe a small scale, 16 inches, something like that. I would actually plug into the back of a JP-3, right? And to where you're converting your battery acid, whatever you want to put in there, your ketchup, it don't matter. Your coffee that you don't drink, you can throw it in there and convert it into a fuel. And the JP-3 pretty well finishes off the mechanics of the Joe pipe into where it is a thermal insert that can be used for practically any application. And you're only limited by your imagination, but you basically got a big element that gets around about 1800 degrees. So it's just a matter of chinking around and making the bodies for it, for it to fit in, whatever you want to do. And you can make a big hot air dryer if you wanted to. Just plug this in, and the heat would be diverted into the plenum, and they have like a big fan. You could heat up a 5,000 square foot, 10,000 square foot building. It wouldn't be that much of a problem. But if you're able to make your own fuel using the gate gas, or even to use the JP-3 SL series, to where you could actually maybe run on 30% water or steam, and that's a big saving right there, especially when fuel's on the way up again. And I believe that we have to prepare. That time is